If Earth vanished tomorrow, would the universe even notice? Stay with me, because in the next few minutes, we're going to travel from this very moment to the end of time itself. And somewhere along the way, everything you've ever known will disappear. Right now, you're living in a tiny blink of cosmic history. Humanity has existed for only a fraction of a second compared to the age of the universe. Our cities, our nations, our triumphs and failures are all unfolding on a small rocky world orbiting an ordinary star. Yet this ordinary moment is the starting point for the greatest journey imaginable. Close your eyes and picture the Earth as it is today. Oceans shimmer beneath drifting clouds. Forests breathe. Millions of species struggle, hunt, grow, and survive. More than 8 billion people wake up, work, laugh, and dream. Satellites circle overhead. Signals race across the planet at the speed of light. Civilization feels permanent. But permanence is an illusion. A few thousand years from now, almost everything familiar will have changed. Languages will evolve beyond recognition. Borders will rise and fall. Entire cultures will become ancient history. The monuments we build today may be buried beneath new landscapes. Future generations will look back at us the way we look back at the builders of the pyramids. 10,000 years pass. Glaciers continue their slow dance across the planet. Coastlines shift. Many of today's greatest cities face the relentless power of erosion and rising seas. Human descendants, wherever they live, will inherit a world that looks both recognizable and strangely different. 50,000 years from now, the last radio broadcasts from our era will have traveled 50,000 light years into space. Somewhere among the stars, those signals will continue moving outward forever, carrying fragments of our voices into the darkness. Whether anyone will ever hear them is another question entirely. 100,000 years pass. The night sky itself begins to change. Stars slowly drift from their current positions. The constellations that guided sailors and inspired storytellers for millennia gradually deform into new patterns. Orion, Ursa Major, and Scorpio will no longer look the way they do tonight. 1,000,000 years from now, Earth remains alive, but evolution continues rewriting the script of life. Species appear and vanish. Continents creep across the planet at the speed your fingernails grow. Mountains rise while others crumble into dust. Time is patient, and it changes everything. 10 million years pass. The Mediterranean may disappear entirely as Africa pushes northward into Europe. New mountain ranges could tower where seas once existed. The map hanging in your classroom would be meaningless. 50 million years from now, Earth's continents continue rearranging themselves. The Atlantic Ocean widens. Australia moves farther north. The planet never stops moving, even when it appears still. 100 million years pass. Most species alive today are gone. Their bones, if preserved at all, rest deep within layers of rock. Future creatures roam landscapes we cannot imagine. Humanity may have transformed beyond recognition, spread to other worlds, or vanished completely. At this distance, all possibilities remain open. 500 million years into the future, the sun grows brighter. Earth's climate begins a long, dangerous transformation. Higher temperatures disrupt the delicate balance that allowed complex life to flourish. The planet that once felt perfectly suited for us becomes increasingly hostile. 700 million years pass. Carbon dioxide levels fall so low that most plants struggle to survive. Forests disappear. Oxygen declines. The great green engine that supported complex ecosystems begins to fail. 1 billion years from now, Earth's oceans start slowly evaporating under the strengthening sun. Rivers vanish. Seas shrink. What was once a blue world gradually becomes dry and barren. If any intelligent descendants remain, they will likely be watching from elsewhere in the solar system. And then, around 5 billion years from today, the real drama begins. The sun exhausts the hydrogen in its core and swells into a red giant. Imagine looking up and seeing a star so enormous that it fills a huge portion of the sky. Temperatures on Earth soar beyond anything life can endure. Oceans boil away completely. Rocks melt. The surface becomes a glowing furnace. Mercury disappears first, swallowed by the expanding star. Venus follows. Earth's fate is uncertain. Some calculations suggest our planet may spiral inward and be consumed. Others suggest it could survive as a scorched, lifeless world orbiting just beyond the sun's outer layers. Either way, the Earth we know is gone forever. For a brief time, the dying sun becomes one of the most spectacular objects in the galaxy. Its outer layers drift into space, creating a vast glowing cloud of gas. At the center remains a white dwarf, a stellar ember about the size of Earth, but containing roughly half the sun's mass. The solar system grows quiet. Mars freezes in darkness. The giant planets continue circling the fading remnant of the sun. Their moons wander through the cold. No sunsets remain on Earth because there are no oceans, no skies, and perhaps no Earth at all. Yet the universe is only getting started. As trillions of years pass, stars continue to form and die throughout the cosmos. Galaxies collide and merge. Black holes consume matter. New worlds appear, while old ones are destroyed. Compared to the future that lies ahead, the entire history of humanity is merely the opening sentence. Imagine standing on a distant world during this era. The Milky Way and the Andromeda galaxy have already collided, forming a single giant galaxy. The night sky is crowded with stars. But beyond the local group of galaxies, something strange has happened. The universe is expanding. Not just expanding, but accelerating. Distant galaxies are being carried away faster and faster by the stretching of space itself. Over unimaginable spans of time, those galaxies disappear beyond the cosmic horizon. Their light can no longer reach us. Future astronomers living in this merged galaxy may look outward and see only darkness, with no evidence that countless other galaxies ever existed. This is one of the greatest cosmic tragedies. The universe will erase its own history. Right now, we can still observe the afterglow of the Big Bang and see galaxies billions of light years away. We live during a rare era when the cosmos is willing to reveal its past. Future civilizations may never know how vast the universe truly was. So remember where we began. A single species on a small planet beneath a yellow star. We worry about tomorrow, while the universe measures time in billions and trillions of years. And this is only the beginning of our journey to the end of time. The stars are dying. We have traveled beyond the age of planets, beyond the lifetime of the sun, and into a future so distant that every human civilization is less than a forgotten memory. Trillions of years have passed. The universe is entering a new era, and the darkness is beginning to win. For a while, the cosmos is still beautiful. Red dwarf stars, the smallest and most efficient stars in existence, continue burning quietly. They use their fuel so slowly that some will shine for trillions of years. If life survives anywhere, these dim stars may become its last refuge. Imagine standing beneath a sky lit by a single red sun. Around it orbit ancient worlds warmed by a faint glow that seems eternal. Entire civilizations could rise and fall millions of times before that little star finally exhausts its fuel. Compared to the violent lives of massive stars, red dwarfs are masters of patience. But even patience has an end. One by one, the last stars consume their remaining hydrogen. Some fade into white dwarfs, others become neutron stars or black holes. New stars stop forming because the galaxies have used up most of the gas needed to create them. The great stellar factories fall silent. The night sky grows emptier. 100 trillion years from now, the age of stars is ending. Almost every star that ever illuminated the universe has burned out. Galaxies are filled with stellar corpses drifting through the darkness. White dwarfs glow faintly like dying embers. Neutron stars spin through the void. Black holes lurk unseen between them. If an observer existed during this time, they would witness a universe transformed beyond recognition. The brilliant spiral arms of galaxies have faded. The colorful nebulae that once gave birth to stars are gone. Only scattered remnants remain, yet strange encounters still happen. Over unimaginable spans of time, stars and stellar remnants pass near one another. Their gravity disrupts planetary systems. Worlds are flung into interstellar space. Some fall into black holes. Others become rogue planets wandering forever without a sun. Picture a frozen planet drifting alone through eternal night. No dawn will ever arrive. Oceans became ice ages ago. Mountains stand beneath a sky without sunlight. The planet travels through the galaxy like a cosmic ghost. And still, time continues. As quadrillions of years pass, white dwarfs cool further and further. Eventually they become black dwarfs, cold, dark objects that emit almost no heat or light. The universe fills with invisible relics. Then, something extraordinary may occur. According to some theories, protons, the particles that make up the atoms in your body, may not live forever. If proton decay exists, matter itself slowly falls apart. The process is unimaginably slow, but given enough time, even mountains, planets, and dead stars begin to dissolve into lighter particles and radiation. A black dwarf that survived for countless ages would gradually disintegrate. Entire worlds would simply fade away atom by atom. Imagine watching a planet disappear, not in an explosion, not in a collision, but in silence. Every rock, every grain of dust, every atom slowly vanishes into the void. The universe becomes less solid with each passing age. By now we have entered the degenerate era. Normal stars are gone. Planets are disappearing. The cosmos is populated mainly by black holes, neutron stars, black dwarfs, and drifting particles. And black holes are becoming the rulers of creation. Anything that wanders too close is captured forever. Stars are torn apart. Gas spirals inward and heats to incredible temperatures. Entire solar systems can vanish into the darkness. At the center of ancient galaxies lie supermassive black holes containing millions or billions of times the mass of the sun. If you could approach one safely, you would see space itself distorted. Light bends around it. Time slows near it. The closer you get, the stranger reality becomes. Suppose you fell toward a supermassive black hole. To a distant observer, you would appear to slow down, fading gradually as you approach the event horizon. But for you, time would seem normal. You would cross the boundary without seeing a sign that says, "You have entered a black hole." Beyond that horizon, every path leads inward. The universe contains objects so powerful that they can trap light itself. For eons, black holes continue growing by consuming whatever remains nearby. They merge with one another in titanic collisions that send ripples through space-time. These gravitational waves travel across the cosmos long after the galaxies that created them have faded away. Eventually, most large structures disappear. Stars are gone. Planets are gone. Even galaxies have been torn apart by countless gravitational interactions. What remains is a sparse universe containing isolated black holes and thin streams of radiation. This darkness lasts for a staggering length of time. Numbers become almost meaningless. Millions of years are tiny. Billions are brief. Trillions pass like moments. We are now dealing with timescales so enormous that writing them out would fill pages with zeros. And then we discover that even black holes are not eternal. In the 20th century, physicist Stephen Hawking showed that black holes should slowly lose energy by emitting what we now call Hawking radiation. The larger the black hole, the slower the process. A supermassive black hole may survive for an almost incomprehensible duration, but eventually it too begins to evaporate. Imagine a black hole that has existed longer than all previous cosmic history combined. It sits alone in the darkness, surrounded by nothing. Very slowly, particle by particle, it loses mass. The process is so gradual that entire universes of human history could pass without noticing any change. Yet the change continues. After unimaginable ages, the black hole becomes smaller. Its temperature rises. It radiates energy faster and faster. The final moments arrive in a sudden burst of particles and radiation. One of the last great giants of the cosmos disappears in a flash. A black hole has died. Across the universe, the same fate awaits every other black hole. One by one, the ancient monsters evaporate. The rulers of creation surrender to time itself. When the last black holes finally vanish, the universe enters a new and terrifying chapter. No stars remain. No planets remain. No galaxies remain. Almost all matter has either decayed or been swallowed and re-emitted as radiation. The cosmos becomes an enormous cold ocean of darkness filled with thinly scattered particles drifting farther apart as space continues expanding. This is not the dramatic end we once imagined. There is no final explosion, no collapsing curtain, no cosmic announcement. Instead, the universe grows quieter. The temperature falls toward absolute zero. Energy becomes increasingly diluted. Distances between particles become unimaginably vast. Encounters become extraordinarily rare. A single particle may travel for ages longer than the lifetime of all stars before meeting another. If consciousness could somehow survive to witness this era, it would experience a universe that feels empty beyond comprehension. No suns would rise. No galaxies would decorate the sky. There would be only darkness, silence, and the slow expansion of space. And yet, unbelievably, we are still not at the end. Because in the next part of our journey, we will travel beyond the death of black holes into a future where the universe approaches heat death, where time itself loses meaning, and where the final question emerges. What happens after everything is gone? Everything that could die has died. The stars are gone. The galaxies have faded. The last black holes have evaporated into faint whispers of radiation. We have traveled farther into the future than any human mind was ever meant to imagine, and yet time continues to flow. This is the era known as the heat death of the universe. Imagine an ocean stretching forever in every direction. Now remove the water, the light, the sound, and the warmth. Replace them with near-perfect darkness and particles scattered across distances so enormous that encounters become almost impossible. That is what the cosmos has become. The universe has not been destroyed. It has simply run out of useful energy. Long ago, differences in temperature powered everything. Hot stars warmed cold planets. Gravity pulled matter together. Explosions created new structures. Life itself depended on energy flowing from one place to another. But after unimaginable ages, those differences have nearly disappeared. Every remaining particle drifts through a cold and expanding void. There are no blazing suns left to light the darkness. No galaxies spinning majestically through space. No worlds filled with oceans and skies. Only a thin fog of particles and radiation spread across a universe that grows larger every moment. If you could stand in this future, there would be nothing to see. The nearest particle might be farther away than entire galaxies once were. Space would feel empty beyond comprehension. And still, the expansion continues. For trillions upon trillions upon trillions of years, space stretches outward. The temperature falls closer and closer to absolute zero. Time loses its familiar meaning because nothing significant seems to happen anymore. Yet physics leaves us with a strange possibility. Even in an almost empty universe, tiny quantum fluctuations can occur. Empty space is not truly empty. It seethes with fleeting activity at the smallest scales. Particles can briefly appear and disappear. Rare events, given enough time, may eventually happen. And when we say enough time, we mean numbers so large that writing them down would barely help. Imagine waiting longer than the entire age of the universe. Then, waiting that long again, and again, and again, more times than there are atoms in all the stars that ever existed. That still would not be enough to describe some of the timescales we are approaching. In such a future, an extraordinary event could theoretically occur. A random fluctuation might briefly assemble matter into a complex structure. Given enough time, it is possible that atoms could accidentally arrange themselves into something astonishingly organized. Perhaps a single molecule, perhaps a rock, perhaps something even stranger. Some physicists have imagined the possibility of a Boltzmann brain, a self-aware mind that appears momentarily out of chaos, complete with memories that were never lived. A consciousness could awaken in the darkness, believing it had a past, a family, a world, and a history, only to vanish almost instantly back into nothingness. Think about that for a moment. Everything you remember could feel absolutely real. Every childhood memory, every friendship, every fear, every dream. Yet such a mind might have existed for only a fraction of a second. It is one of the strangest ideas in all of cosmology. But the universe may become stranger still. Some theories suggest that empty space itself may not be perfectly stable. What if the vacuum of the universe is only a temporary state? What if there exists a lower energy state waiting beneath it? If that is true, a catastrophic event called vacuum decay could occur. Without warning, a tiny bubble of true vacuum would appear somewhere in the cosmos. It would expand outward at nearly the speed of light. Inside that bubble, the laws of physics could be completely different. Atoms might no longer hold together. Chemistry might cease to exist. Every structure in its path would be erased instantly. The terrifying part is that we would never see it coming. Because the bubble travels at the speed of light, its arrival and the first possible warning would happen at the same moment. One instant you would be watching the stars. The next instant, everything would be gone. Thankfully, we have no evidence that such a catastrophe is about to occur. It remains a theoretical possibility, not a prediction. But it reminds us that the universe still holds mysteries deeper than we can fully understand. As the ages continue, the cosmos approaches a state of maximum entropy. Entropy is often described as the tendency toward disorder. But in this context, it means something even more profound. Energy becomes evenly distributed. No significant gradients remain. Nothing is left to power large-scale change. The universe becomes a vast equilibrium. No new stars ignite. No civilizations rise. No great structures form. The cosmos settles into a cold, quiet stillness that could last forever. Imagine the final campfire after every traveler has gone home. The flames have died. The ashes are cold. The wind has stopped. The night stretches endlessly in all directions. That is the feeling of the heat death. And yet, one final question remains. Is forever truly forever? For centuries, people have asked whether the universe had a beginning. The Big Bang gave us one answer, but another question has always lingered in the shadows. Will the universe have an ending, or a new beginning. Some cosmologists have proposed that the cosmos could be cyclical. In one version, the expansion eventually reverses. Galaxies stop racing apart and begin falling back together. Temperatures rise. Matter becomes compressed into a state beyond imagination. The universe collapses in a great crunch, perhaps giving birth to another Big Bang. In another version, our universe is only one bubble in a vast multiverse. New universes may constantly emerge while others fade away. Space could be filled with countless realities, each with different histories, different laws, and different possibilities. And then there is the idea of eternal inflation. According to this picture, the expansion that created our universe may never have completely stopped. New regions of space continue inflating, creating new universes forever. If that is true, somewhere beyond everything we can observe, new cosmic beginnings may be happening right now. Imagine that. While our universe drifts toward darkness, another may be experiencing its first stars, its first galaxies, perhaps even its first living beings looking up and wondering where they came from. We do not yet know which of these ideas, if any, is correct. The evidence points strongly to an expanding universe that may continue expanding forever, but the ultimate fate of reality remains one of science's greatest mysteries. So let us return to the present. After traveling through billions, trillions, and unimaginable stretches of time, we arrive back at this moment. Your screen glows in a small corner of a spiral galaxy. Outside, the Earth spins through space at thousands of miles per hour. The sun shines quietly above us. The stars still fill the night. Everything we have seen on this journey, the death of Earth, the fading of the stars, the reign of black holes, the cold emptiness of heat death, lies far beyond any human lifetime. Yet it is connected to us. The atoms in your body were forged inside ancient stars that exploded long before Earth existed. You are made of cosmic history. That may be the most remarkable fact of all. The universe spent billions of years creating stars, planets, oceans, and life. Eventually, on one small world, it produced beings capable of asking questions about their own existence. Through us, the cosmos became aware enough to wonder how its story ends. And perhaps that is why this journey matters. Not because we will witness the end of time. We almost certainly will not. Not because humanity will survive forever. No one knows whether it will. This journey matters because it reveals the incredible scale of the reality we inhabit. Every argument, every achievement, every heartbreak, every act of kindness takes place during a brief and precious era when stars still shine and life is still possible. We live in a universe young enough to be filled with light, yet old enough to create consciousness. One day, the last star will fade. One day, the last black hole will evaporate. One day, the universe may become a cold and silent expanse where nothing familiar remains. But today is not that day. Right now, oceans still move beneath the moon. Forests still grow. Cities still glow in the darkness. Somewhere, a child is seeing the Milky Way for the first time. Somewhere, a scientist is discovering a new secret of the cosmos. Somewhere, someone is looking up and asking the same question that has echoed through human history. What is our place in all of this? Maybe the answer is not that we are insignificant. Maybe the answer is that we are a tiny part of something unimaginably vast. A universe that began in fire, evolved into galaxies, and produced minds capable of dreaming about eternity. From the first fraction of a second after the Big Bang to the possible heat death of the cosmos, the story of the universe spans a scale beyond comprehension. And somehow, against impossible odds, we arrived in the middle of that story. So the next time you step outside at night, Look up. Those stars are not just distant lights. They are the ancestors of every atom in your body and the witnesses to a future that stretches beyond imagination. We began this journey with a question. If Earth vanished tomorrow, would the universe even notice? Perhaps the universe notices through us, through every mind that wonders, every eye that looks into the darkness, and every voice that asks what lies beyond the horizon of time. This has been our time-lapse of the future, a journey from the world we know to the farthest future science can imagine, from the birth of stars to the silence after their deaths, from the rise of life to the edge of eternity. And somewhere in that endless expanse, our brief moment still shines. The end of time may be unimaginably far away, but tonight, the universe is alive. And so are we. We have reached the farthest shore that science can see. Behind us lies the birth of the universe, the rise of galaxies, the formation of Earth, the appearance of life, and the long age of the stars. Ahead of us is a darkness so deep that language struggles to describe it. Imagine the universe after every star has burned out, after every galaxy has faded, and after the last black hole has vanished into a whisper of radiation. Space continues expanding, carrying the remaining particles farther and farther apart. The cosmos becomes cold, thin, and almost perfectly still. For an unimaginably long time, nothing changes. No dawn breaks across a planet. No comet streaks through a sky. No civilization sends signals into the void. The universe drifts through an endless night where the distance between events becomes greater than the distance between galaxies once was. And yet, physics refuses to let the story end cleanly. Even in the emptiness, tiny quantum fluctuations may still occur. Space itself is restless. Given enough time, rare events that seem impossible can become possible. A particle may appear, a burst of energy may emerge. Somewhere in the darkness, the universe may briefly surprise itself. Some scientists have imagined that entirely new regions of space could be born from such processes. Others think our universe may be one of countless universes in a much larger reality. We do not know which idea is correct. We only know that the deeper we look into the cosmos, the stranger it becomes. Perhaps there are other universes where stars are just beginning to ignite. Perhaps there are worlds where oceans are forming for the first time. Perhaps somewhere, another civilization is looking up at its night sky and asking the same question we asked at the beginning of this journey. How does it all end? The truth is that no one knows for certain. The universe may continue expanding forever into a cold heat death. It may undergo a transformation we have not yet discovered. It may be part of a larger cosmic cycle beyond our understanding. The final answer remains hidden beyond the edge of present knowledge. But while the ending is uncertain, one thing is undeniable. We live during an extraordinary moment. Out of all the ages of cosmic history, we exist in the brief era when stars still shine, galaxies are still visible, and life is still possible. The universe is old enough to contain billions of years of history, yet young enough that the lights of creation have not gone out. Right now, our planet circles an ordinary star on the outskirts of the Milky Way. The moon pulls at the oceans. Forests breathe. Storms cross continents. People fall in love, tell stories, build cities, and dream about the future. Everything humanity has ever accomplished has happened during this tiny window of time. Every work of art, every scientific discovery, every act of courage, every laugh, every tear, every memory. Compared to the lifespan of the universe, all of it fits into a single heartbeat. And yet, that heartbeat matters. We have reached the farthest shore that science can see. Behind us lies the birth of the universe, the rise of galaxies, the formation of Earth, the appearance of life, and the long age of the stars. Ahead of us is a darkness so deep that language struggles to describe it. Imagine the universe after every star has burned out, after every galaxy has faded, and after the last black hole has vanished into a whisper of radiation. Space continues expanding, carrying the remaining particles farther and farther apart. The cosmos becomes cold, thin, and almost perfectly still. For an unimaginably long time, nothing changes. No dawn breaks across a planet. No comet streaks through a sky. No civilization sends signals into the void. The universe drifts through an endless night, where the distance between events becomes greater than the distance between galaxies once was. And yet, physics refuses to let the story end cleanly. Even in the emptiness, tiny quantum fluctuations may still occur. Space itself is restless. Given enough time, rare events that seem impossible can become possible. A particle may appear. A burst of energy may emerge. Somewhere in the darkness, the universe may briefly surprise itself. Some scientists have imagined that entirely new regions of space could be born from such processes. Others think our universe may be one of countless universes in a much larger reality. We do not know which idea is correct. We only know that the deeper we look into the cosmos, the stranger it becomes. Perhaps there are other universes where stars are just beginning to ignite. Perhaps there are worlds where oceans are forming for the first time. Perhaps somewhere, another civilization is looking up at its night sky and asking the same question we asked at the beginning of this journey. How does it all end? The truth is that no one knows for certain. The universe may continue expanding forever into a cold heat death. It may undergo a transformation we have not yet discovered. It may be part of a larger cosmic cycle beyond our understanding. The final answer remains hidden beyond the edge of present knowledge. But while the ending is uncertain, one thing is undeniable. We live during an extraordinary moment. Out of all the ages of cosmic history, we exist in the brief era when stars still shine, galaxies are still visible, and life is still possible. The universe is old enough to contain billions of years of history, yet young enough that the lights of creation have not gone out. Right now, our planet circles an ordinary star on the outskirts of the Milky Way. The moon pulls at the oceans. Forests breathe. Storms cross continents. People fall in love, tell stories, build cities, and dream about the future. Everything humanity has ever accomplished has happened during this tiny window of time. Every work of art, every scientific discovery, every act of courage, every laugh, every tear, every memory. Compared to the lifespan of the universe, all of it fits into a single heartbeat. And yet, that heartbeat matters. The atoms in your body were forged in ancient stars that lived and died long before Earth existed. The iron in your blood, the oxygen in your lungs, the calcium in your bones were created in the furnaces of stellar explosions. You are not separate from the universe. You are one of the ways the universe has learned to look back at itself. Think about the odds of that. After billions of years of cosmic evolution, matter became life. Life became conscious. Consciousness began asking questions. And eventually, a species emerged that could imagine the birth of the cosmos and the death of time. That species is us. We may never travel to the edge of the observable universe. We may never witness the last star fade or the final black hole evaporate. But we can understand that those events will come. We can trace the story forward with mathematics, observation, and imagination. That is one of humanity's greatest achievements. As we return from this time-lapse of the future, the present feels different. The worries that consumed us a moment ago seem smaller against the backdrop of eternity. The night sky no longer looks like a ceiling. It looks like a history book written in light. Some of the stars above you have already died, though their light is still traveling toward Earth. Others will continue shining long after every human alive today is gone. Beyond them lie galaxies, clusters, and distances so vast that even light needs millions or billions of years to cross them. And somewhere far ahead in time, the universe will become dark and silent. The oceans of Earth will disappear. The sun will become a white dwarf. The stars of the Milky Way will fade away. Black holes will dominate the cosmos and then vanish. Space will grow colder, emptier, and quieter than anything we can truly imagine. That is the future awaiting But tonight, none of those things have happened. Tonight, the Earth is still blue. Tonight, the sun will rise again. Tonight there are people sharing meals, listening to music, falling asleep beneath the stars, and wondering what tomorrow will bring. And perhaps that is the most beautiful part of this story. The universe does not promise permanence. It does not guarantee that stars, planets, or civilizations will last forever. Yet in the middle of this vast and temporary cosmos, life appeared. For a little while, the darkness learned how to sing, to think, and to dream. We began with a question. If Earth vanished tomorrow, would the universe even notice? Maybe the better question is this: what does it mean that the universe produced beings capable of noticing themselves? From the first instant after the Big Bang to the possible heat death trillions upon trillions of years from now, the story of existence stretches across a scale beyond comprehension. And somehow, against impossible odds, we arrived here, in the middle of that story, with enough time to look up and wonder. So the next time you stand beneath a clear night sky, remember that you are seeing only a tiny chapter of a much larger tale. Those distant stars are the remnants of the past. The darkness between them hides the future. And you, for this brief moment, are alive between the two. This has been The Future of Everything, a time-lapse journey to the end of time. From the birth of the cosmos to the fading of the last light, we have traveled farther than any human could ever go. We have watched worlds appear and disappear, stars ignite and die, galaxies collide, black holes evaporate, and time itself approach eternity. And after all of that, one truth remains. The universe is unimaginably vast. Our lives are incredibly brief. But while we are here, we are part of the greatest story ever told. The end of time may be beyond imagination, but tonight, the stars still shine, the universe is still awake, and so are we.